Multiplying and dividing rational expressions. So for example, x squared plus 2x minus 8 divided by x squared plus 4x plus 3 times 3x plus 3 over x minus 2. Our first step will be to factor everything that we can. So let's start with the numerator of the first fraction. So set up the two parentheses. I'm looking for numbers that multiply to negative 8 but add up to positive 2. Fill in my x's with plus 4 and negative 2. And then my denominator, set it up. Looking for numbers that multiply to 3 but add up to 4. And we'll go with plus 3 and plus 1 times. Okay, then the numerator, we've got 3x and we've got 3, so let's factor out a greatest common factor of 3. That leaves 3 times x plus 1, and then the x minus 2 is as factored as it can be. Second step, cancel common factors. So we need to see factors that appear in both the numerator and denominator and cancel them out. So x plus 1 is here in the denominator, and here in the numerator. We cancel them out, we replace them with 1s. Okay, we can also cancel out the x minus 2's. And so now we are left with an x plus 4 and a 3 in the numerator and an x plus 3 in the denominator. Step 3, multiply across. So we would multiply 3 times the x plus 4 in the numerator, and in the denominator we have the x plus 3. Okay, you could technically distribute in the numerator, but it's usually better and easier just to leave it factored like we have it. So we could put 3x plus 12 over x plus 3, but 3 times x plus 4 over x plus 3 also serves what we need. Example 2. X plus 2 over x plus 3 divided by x squared plus x minus 12 over x squared minus 9. So the first step, when we're dividing fractions, we want to multiply by the reciprocal. So we want to keep the first fraction the same, change the divide to multiply, and flip the second fraction. So we get x plus 2 over x plus 3 times x squared minus 9 over x squared plus x minus 12. Step 2, factor. Our first fraction looks good. Okay, the numerator is a difference of squares, or if we forget that, we can look for numbers that multiply to negative 9 but add up to 0. So we get x plus 3, x minus 3. And then the denominator, we'll look for numbers that multiply to negative 12 but add up to positive 1. Those are x plus 4 and then minus 3, so x minus 3. Third step, cancel common factors. So we can cancel x plus 3's, replace them with 1's, and we can cancel x minus 3's. So as we've been doing this, notice when we look for factors to cancel, they can be in the same fraction or they can be in different fractions. What's important is that we are canceling a factor in the denominator with something in the numerator. Okay, so now we're left with an x plus 2 in the numerator and an x plus 4 in the denominator. So multiply across, and we are left with x plus 2 times a bunch of 1's over x plus 4 times a bunch of 1's, or x plus 2 over x plus 4. Okay, our last example is called a complex fraction. And it looks a bit complicated. But our first step, we're going to simplify this by just writing it as a simple division of fractions. So we take our numerator, which is x squared over x squared minus 25y squared, write divide, and then take our second fraction, x over x minus 5y. So this is like what we just did in example 2. So now, second step, multiply by the reciprocal. So keep the first fraction the same, change divide to multiply, and flip the second fraction. Next step, factor. Okay, our numerator is good. Our denominator is a difference of squares, perfect square minus in between. So two sets of parentheses. Square root of the first term is x. Square root of the second term is 5y. One gets a plus, one gets a minus. Okay, our numerator, our second fraction doesn't need to be factored. It's already in simplest terms. Step 4, cancel common factors. We can cancel the x minus 5y's, and then this 1x can cancel with one of the x's in the numerator here, so the x squared changes to an x to the 1, and then multiply across. So x times 1 is x, and x plus 5y times 1 is x plus 5y, and that's our answer.